Clap detection is a good example for digital filtering. We'll use a microphone assembly to capture audio data. We'll filter the data, then use histograms to identify features that might correspond to claps. Let's take a look at the setup. The setup includes an Arduino, the audio module, and a USB oscilloscope so we can look at the signals. The audio module includes a microphone and an amplifier. It has both digital and analog outputs. The digital output will detect a sound level. We can adjust the level with a screwdriver that sets the value of a resistor. We'll use the analog output. Here's a waveform for a clap. We can decimate the signal to reduce its sample rate, then use a histogram to describe the overall shape of the signal. We can compare the signal's histogram to a template histogram in order to see whether we've matched what we're looking for. In order to decimate the signal, we add together several successive samples of the waveform. Once we've collected the number of samples that corresponds to the rate at which we're decimating the signal, we will take that sum, divide it by the number of samples in order to get an average value, and then we'll put that into a buffer. The add decimate function builds a circular buffer to hold the latest several values of the decimation. This code tests whether we've wrapped around the buffer in order to go back to the beginning. The isClap function tests the decimated signal against a template histogram. The histogram uses two thresholds to build a shape with a peak and a tail. To summarize, we used a microphone assembly with an amplifier to capture audio data. We decimated the signal to reduce its sample rate. We compared the decimated signal to a histogram to identify features that might correspond to a clap. Thanks for watching.